All right, we need to do some practice problems here to get a handle on exactly what it is that we're working with. So what we need to do is start off by finding the degree of each of the monomials in this set. So let's see. 3x squared y z to the sixth. That's a monomial because I have a variable times a variable times a variable all of them are raised to whole number exponents, and then the constant out front doesn't really matter. There's a constant out front too, but it has a degree of 0, so we're not interested in that. All right, so let's do letter A. For letter A, we have to add together the exponents of the variables. 2 plus 1 plus 6. This has a degree of 9. Letter B, this monomial, 2 to the third. I do not care about that variable of the exponent of the constant. I only care about exponents of variables. So this is 1 plus 1 plus 1. Each of these has an exponent of 1, 3. All right, let's do letter C. Letter C, again, I don't care about the exponent on the constant at the beginning, but on the variables, 1 plus 2 plus 3 is 6. And that's A, B, and C. All right, let's move on to letter D. We need to write each polynomial in its standard form. That's actually not too hard to do. I just have to find the one with the greatest degree, and it goes first, followed by the one with the next greatest degree. So this is, let's see, 2w to the fourth has the highest degree. So this one's going to be negative 2w to the fourth plus 3w squared. Now notice my careful negative management that's going on here. Anything that's got a minus in front of it, I have to record it as negative. So I can't just say 2w to the fourth. It's negative because there's a minus in front of it. And then the first term was positive. So if I flip this around in front, I need to make sure I carry the negative with this one. But now they're being added. So I need to make sure I add a positive 3w squared. This is where being careful with negatives is going to pay off if you understand it, because these are a little bit difficult to keep track of, and you really have to work at it, but it's really important. All right, this next one. Which one has the greatest degree? This one has a degree of 3, 4, 2. The 4 has the greatest degree. So this is going to be 3a squared b squared has a degree of 4 when I add together all of the exponents. Okay, next I'm going to have plus 5ab squared, which has a degree of 3. Next, I'm going to add 8ab, which has a degree of 2. So we'll add 8ab. And then minus 1. Minus 1 goes last. It has a degree of 0 because it doesn't have any variables with exponents. And then finally, letter F. Let's see, which one has the greatest degree? 5a squared b is a degree of 3. I have to make sure I carry the negative with me. So it's going to be negative 5a squared b, degree of 3. Next, it's going to be plus 2ab. Notice 2ab is positive, so I'm going to make sure that when I put that one in, I'm going to insert it as a positive number. And then minus 7, which has a degree of 0. Now, what is the leading coefficient for each of these? The leading coefficient is the coefficient of the term that has a highest degree. So it's always going to be the first term. The leading coefficient for D is going to be negative 2. For letter E, my leading coefficient is 3. Because the term with the highest degree has a 3 in front of it. And then for letter F, my leading coefficient is negative 5. When I have them in standard form, the first coefficient of the first variable term is just the leading coefficient. All right, letter G. Let's go ahead and slide these over a little bit here. And then we're going to do G just to make sure I have enough room for everything. Let's do G up here. So letter G asks me to add the polynomials. What I have to do is add the like terms. Now I'm going to use the associative property of addition and note that even though this is a polynomial and this is a polynomial, I can get rid of the parentheses and associate anything I want. I'm going to associate 2x squared and x squared. I'm going to associate 8 and 4 as I add things that I can add. I can't add 2x squared to just x because they have different variable sets. Remember, I can't add things that have different variable sets. That includes exponents that have to be the same as well. So, like, remember, and just kind of think about this. This is x times x, okay? X squared is x times x. X times x is a different value than just x by itself. So, if I have two x times x's and one x, it doesn't make sense for me to say I have three x times x's. That's why I can't just add these together. I have to keep these separate. But if I have two x times x's and then plus another x times x, then I can say I have three x times x's. You get my drift? So here we go. This is going to be 3. When I add those two together, it's going to be 3x squared. Okay, I'm just adding the like terms. Plus, there's only one x. There's no other term that contains an x. So it's just that one x. And then plus 12. 8 and 4 can be added, and that's it. That's the most I can simplify letter G. Letter H is going to be sort of the same thing. I can combine the 3n squared minus 2n squared. I have 3n squared, so I'm going to subtract 2n squareds. So I'm going to have just 1n squared left, and then I don't have to write the 1. So it's going to be n squared plus 7n minus n plus 7n minus n is plus 6n. 7n's minus 1n is 6n's. And then plus 1, let's see, minus 1 plus 1. Well, those are just going to cancel. So I have no constant term. N squared plus 6n is the answer. All right, letter I, pay attention. Negative management. All right, now, here's where it may pay off to do something to make these a little easier. Maybe we want to invoke the associative property and just remove all of the parentheses here to make this easy. If you don't do this, I'm almost going to guarantee that you're going to at least a couple of times mix up your negatives, and you're going to really struggle with negatives management. So it's 12y cubed plus 10. Now I'm subtracting the entire second polynomial. What does this minus sign out front do? This minus sign is going to affect 18y cubed. It's going to affect negative 3y squared, and it's going to affect plus 5. This negative basically distributes to all three terms. It's going to change the sign of everything in parentheses after it. So this becomes plus 18y cubed. It becomes plus, hold on. It's minus, what am I doing? Minus 18y cubed, and then plus, the next one is plus 3y squared, okay? And then minus 5. Notice that the minus out front changed the sign of everything individually in parentheses. Everything's sign is different. Well, now that I've done that, though, I could just simply add them. 12y cubed minus 18y cubed is negative 6y cubed. All right, you have to be good. At this point, you should be really good at adding positives and negatives like that. Plus, well, I only have one y squared term. It's 3y plus 3y squared. And it is plus 3y squared, not minus anymore. Okay, there we go. And then plus 10 minus 5 is just plus 5. Plus 10 minus 5 is 5. This is my answer for I. Let's do J. J is c squared. Okay, once again, I'm just going to do this. C squared plus 6c minus 2. Okay, associative property, getting rid of parentheses, doesn't matter. But now this minus in front of the parentheses is going to change the sign of everything in parentheses. So it's going to be minus c squared plus 2c okay, minus 6. Everything in the parentheses got its sign changed because this negative basically distributed to all three things. C squared minus C squared. Ooh, my squared term is just going to disappear because C squared minus C squared is 0. All right, but I am going to have a C term. 6C plus 2C is 8C. And then minus 2 minus 6 is minus 8. 8C minus 8. That is my answer. All right, then finally, K. Hector throws a baseball up into the air, and at the same time, Jonas throws another baseball upward. The expressions below represent the heights of the baseballs at time t. Write an expression for the difference in height between the two throws. So we're going to have negative 16t squared plus 22t plus 4 minus negative 16t squared. So I'm just subtracting the second expression from the first. Minus negative 16t squared plus 17t plus 6. Okay, now this minus is going to change the sign of everything in parentheses. So let me just copy this. And then let's change the sign of everything. It's going to become plus 16t squared. Okay. And then minus, because it changed the sign, minus 17t minus 6. Okay. And now I just have to do the addition. Well, negative 16t squared plus 16t squared is going to cancel. They perfectly cancel each other out. 22t minus 17t is 5t, and plus 4 minus 6 is minus 2. My answer when I subtract these polynomials is 5t minus 2. All right, so once again, when adding polynomials, you just add the like terms. Really easy. These were adding polynomial problems. When subtracting polynomials, you have to remember that the polynomial that you're subtracting, you have to change the sign of every term in the polynomial and then add them. Okay, so you're changing the sign of each term and then adding like terms together. It just becomes an addition problem because all subtraction is really addition. It's just adding the opposite. All right, that's how you do these problems. You should be able to do numbers 1 through 34 next time.